July 1st, 2025. A routine sweep of the southern sky. The Atlas telescope on Cerro Tololo, Chile, is doing what it does every clear night, scanning for city killers, cataloging the usual parade of rocks and ice. At 03:17 UTC, the software flags an object that refuses to fit any known orbit. It is moving 60 kilometers per second, hyperbolic, unbound. In plain language, it is not from here. Astronomers call it 3I Atlas. To the rest of us, it is simply the stranger. And in the next 72 hours, it will do something no interstellar visitor has ever done in recorded history. It will reach perihelion, the closest point to our sun, tomorrow night. This is the minute-by-minute account of what happens next. Start with the numbers, because numbers don't lie. The comet is roughly 1 kilometer wide, give or take. That's a city block of ancient ice and metal hurtling through space faster than any human craft has ever traveled. It crossed Neptune's orbit in February, Jupiter's in August, and last week it slipped inside the asteroid belt without grazing a single rock. Right now it is 1.6 astronomical units from the Sun, 1 AU being the average Earth-Sun distance, so about 240 million kilometers. Tomorrow it drops to 1.4 AU. That sounds distant until you remember the Sun's heat rises with the square of the distance. At perihelion, the surface temperature of the nucleus will spike from -200 Celsius to +400 in a single day. Ice that has been solid since before Earth existed will turn to vapor in the time it takes you to brew coffee. Dr. Kwanjai Yi is a comet hunter at the University of Maryland. I reached him at the observatory in Maui, where he was calibrating a spectrograph. His first words were, "We are watching a star forge in real time." He wasn't being poetic. 2 weeks ago, the comet began venting nickel vapor, glowing at 5,800 angstroms, a spectral line you normally see in the atmospheres of white-hot stars, not in the breath of a dirty snowball. Nickel requires temperatures above 1,500 Celsius to sublimate. Something inside the nucleus is acting like a blast furnace. Yi's team ran the models. The only heat source powerful enough is radioactive decay, probably aluminum-26, a short-lived isotope cooked in the supernova that birthed the comet's home system. In other words, the stranger is still radioactive, with the death throes of a star that exploded long before our sun ignited. Now zoom out to the control rooms. In Pasadena, the Zwicky transient facility is grabbing images every 30 seconds. In Tokyo, the Subaru telescope is splitting the comet's light into 1,000 colors. In space, the Hubble Space Telescope has been granted emergency time, its agging gyroscopes spinning like a marathon runner on the final lap. Every dataset streams to a server in Garching, Germany, where a pipeline built for exoplanet hunting has been repurposed to track the stranger's every cough and shiver. The lead software engineer, a woman named Anna Tors, told me the data volume is like drinking from a fire hose made of light. They are measuring the coma, the glowing envelope, at 100,000 kilometers wide and growing. That is 8 times the diameter of Earth. Inside that cloud, 180 kilograms of dust are being ejected every second. Do the math, 10 tons a minute, 600 tons an hour. By perihelion, the comet will have shed the mass of the Eiffel Tower and left it drifting in the vacuum as a glittering trail we will never sweep up. Here is where the story turns investigative. On October 14, a graduate student named Aoi Tanaka at Kyoto University noticed an anomaly in the light curve. A light curve is simply how bright the comet gets as it rotates. Most comets pulse once per rotation, like a lighthouse. 3I was pulsing twice. Tanaka reran the data through a machine learning classifier trained on asteroid breakups. The result came back 98% confidence. The nucleus is splitting. Not tomorrow, not next week, right now. A fissure, maybe a few hundred meters long, is propagating through the ice. Thermal stress is the culprit. The dayside bakes while the nightside remains frozen. The temperature gradient is 1,000,000 times steeper than any engineer would allow in a bridge. If the crack reaches a pocket of volatile gas, carbon monoxide, or molecular nitrogen trapped since the comet formed, the pressure will blow the nucleus apart like a champagne cork. We may wake up on October 30 to 2 comets where there was one, or a string of fragments glowing like embers. Let's follow the timeline hour by hour. Tonight, October 28, the comet is still 36 hours from perihelion. Its speed relative to the Sun is 52 kilometers per second and increasing. The coma is spherical, almost textbook, but the tail is beginning to stretch sunward, a phenomenon called a gas tail, driven not by radiation pressure, but by the solar wind's magnetic field lines snapping and reconnecting. Every flare on the Sun sends a pressure wave that reaches the comet 8 minutes later. We saw one yesterday, a coronal mass ejection that lit up auroras as far south as Arizona. That same plasma cloud is now slamming into the comet, compressing the coma on the sunward side and stretching it into a needle 1,000,000 kilometers long. Spectroscopists call it the iron curtain because ions in the solar wind are glowing blue. Tomorrow morning, 0600 Universal Time. The comet crosses the frost line for carbon monoxide, the distance at which co-ice sublimates. Outgassing will jump by a factor of 10. The European Space Agency's solar orbiter, normally parked to study the Sun, has been maneuvered to a vantage point 0.3 AU away. Its cameras will capture the moment the nucleus brightens by 2 magnitudes in under an hour. That is the astronomical equivalent of a camera flash in a coal mine. Perihelion itself occurs at 03:42 UTC on October 30. For 4 minutes, the comet is closer to the Sun than the planet Mercury ever gets. The surface velocity of the sublimating gas will exceed the local escape velocity. Translation: the comet is trying to blow itself apart. Radar observations from Goldstone and Arecibo, the last 2 big dishes still capable of pinging solar system objects, will fire 400 kilowatt beams at the nucleus. The echo will tell us if the crack has widened to a canyon. If the nucleus fragments, each piece will develop its own coma and tail, creating a celestial necklace visible in small telescopes for weeks. Post-perihelion, the real science begins. As the comet recedes, the dust tail will lag behind, forming a curved arc that traces the orbit like a contrail. That arc is a fossil record. Every grain carries isotopic ratios, oxygen 16 to oxygen 18, deuterium to hydrogen, clues to the temperature and pressure when the comet formed. The James Webb Space Telescope has a 3-hour window on November 15 to map those ratios in infrared. Mission planners had to cancel a scheduled exoplanet observation, the Comet 1. Dr. Stephanie Millam, Webb's deputy project scientist, told me, "We are trading one alien world for another, and we may never get the chance again." By December 19, the comet reaches its closest point to Earth, 1.8 AU, still 270 million kilometers away, perfectly safe. Amateur astronomers with 8-inch telescopes will see a faint smudge near the star Beta Virginis. Apps like Stellarium will overlay the position in real time. For one night, the stranger will be the brightest comet in the sky, magnitude 10, invisible to the naked eye but immortal in a 30-second exposure on a smartphone tracked to the stars. Then it leaves. By March 2026, it will cross Mars' orbit outbound. By 2030, it will be beyond Neptune, its tail collapsed, its outgassing silenced. The nickel vapor will have condensed into microscopic whiskers, each one a perfect crystal reflecting sunlight like a mirror. Those whiskers will drift in the dark for millions of years, eventually to be swept up by another star, another planet, perhaps another curious species that will wonder where the metal came from. Stand back, and the story is almost too large for the human mind. A relic from the birth of an alien solar system has traveled farther than any probe we will launch in our lifetimes, only to be cremated in our sun's fire and scattered as ash across the galaxy. Yet every atom it leaves behind is a data point. The European Space Agency is already designing a sample return mission to fly through the dust trail in 2027, a spacecraft no bigger than a washing machine that will open a collector the size of a pizza box and try to catch a single grain. If it succeeds, we will hold in our hands a piece of another star's childhood. The investigative thread ends where it began, with a quiet telescope on a Chilean ridge. The Atlas team will keep scanning long after 3I vanishes. Statistically, another interstellar object arrives every few years. The next one might be rocky or metallic, or some whisper artificial. We will be ready because we have practiced on this one. The stranger taught us how to listen to the dark. So tonight, step outside. Find a dark patch of sky. You won't see the comet yet, but you will feel the weight of what is happening 240 million kilometers away. A worldlet older than Earth is cracking open, exhaling its secrets in fire and metal. Tomorrow it will be gone, changed forever, and so will we. Because for one brief orbit, the universe looked us in the eye and said, "You are not alone in the dark. You never were."